let's use the binomial probability equation to give ourselves the probability of having a certain number of successes or a certain number of outcomes that we're interested in. Let's look at example 9.2. As of 2020, 13 out of every 100 Americans smoke. If you were to stop 10 people on the street, what is the probability that exactly 3 of them smoke? So this should scream binomial probability distribution, because you're looking for a certain number of successes, right? A certain number of smokers out of 10 people. So here's our equation. The probability let's let S be a variable that counts our successes. So the probability of us having X successes, we need the probability of success, and we're looking for X of those. So we need a success and a success and a success. So we're multiplying the probability of success by itself X times, because we need X successes, which means that we need N minus X. So if we have N trials, then we need the N minus X of them, or the rest of them, to be failures. But this right here, as it stands, is just me finding the probability of having X successes and then the rest failures. I don't care if all of my successes are at the beginning. I just want there to be X of them. So I need to multiply by the number of ways that there can be X successes in these N trials. So using this equation, the probability of smoking is 13 out of 100, which means that the probability of not smoking is 87 out of 100. We have 10 people on the street, and we are looking for 3 of them to be smokers. So the probability of getting 3 smokers will be a smoker occurring 3 times and a non-smoker occurring the 10 minus 3 times, or 10 minus 3 is 7. Right? These 2 exponents should always add to be n, the number of trials. You want 3 smokers, and you want the rest of them to be non-smokers. But again, you don't care about the order of these 3 smokers. You just want there to be 3 of them. So you need to multiply by the number of ways, the number of ways to have 10 people and to choose 3 of them to be smokers. So if we go through this, 10 choose 3, remind yourself of what that equation is. Or rather, let's do it in general. N choose S is n factorial over n minus s factorial, s factorial. So 10 choose 3 gives us 120. And then 13 divided by 100 and then cubed gives us about 0.002197. And the non-smokers happening 7 times. So 87 divided by 100, and then to the 7th is 0.377255. When you multiply all these probabilities, when you multiply all these numbers together to give yourself the probability of having exactly 3 smokers out of a group of 10, this gives you 0.099459, or 9.9, let's say 5%.